Hi guys, welcome back to the channel. So today we are going to be solving today's lead code question, which is word search. So we are given a grid, which is m cross n, and then we are also given the word, and then we need to return true if this particular word is exist in this particular grid. Now, suppose if we take this particular example where we have A, B, C, and then this particular grid. Now we need to find whether we have this particular word in this particular grid. Suppose if I have here A, I have B and then C and then again E. I have, if I compare like this, then I have A, B, C, E. Now if I compare downside, then we are going to have A, S, A. And then if we compare A, S, F, it is like this. So at every stage we have four different points where we can go to. Suppose let's take this particular example where I have at F. Now I have four possibilities. I can go to B, I can go to C, I can go to D, and then I can go to S. So these are the four different steps which I can take from this particular cell. Now when I come to this particular case, here also I have four possibilities, but this next possibility is going to be out of bounds, so we'll not be considering this particular case. Why? Because this will be out of bounds. Suppose when I want to check for all the characters which are present. Suppose let's say I'm not given word equal to A, B, C, and then C, and then E, and then D. Now let's say I was given one more string which is S, E, and then again E. Now I have this particular word. We need to figure out whether this particular string is present in this particular grid or not. Now if I consider at the starting itself, from the starting we have different steps. Now we need to compare that this particular string starts with this particular character or not. So this is not starting with the S, so we'll not be doing any operation from this particular cell. And then again we'll start from B. B is not equal to S, so we'll not be doing any operation on this, so we'll be moving to the next iteration. And then this one also is not S, so we'll not be moving. And then for this, this is not equal to S, so that's why we'll not be doing any operation on this. For this we have the operation equal to the character will be matched, S and then S is matched. So we'll move to the next character which is present in this word, and then from this particular cell we need to traverse to another cell which will match at this particular point. Suppose let's say I'll move to F. Suppose if I move to F, F will not be equal to E, so we'll not be doing any operation on this, so we'll be returning false from this. So if I take this particular direction, if I build the string using this particular direction, I'll not be getting this particular word which is SEE. Why? Because the second character is not matched. Suppose if I take this particular direction, then it becomes SA. A is not equal to E, so we'll return false from this. And then from this we are going to return false. Why? Because this is not matched. Now if I come back here again, then SA, which is not equal to SE, so we'll be returning false. So from this particular cell it is not possible to build this particular string, so we are going to return this particular false. And then we'll move to next cell which will start from again here 0. Now Z, F and S is not same, so we will not be traversing from this particular cell. And then again from this particular cell we will not be doing any traversal. Suppose if I take this particular cell, now S and S is matched, so we'll traverse from this particular cell. From this particular cell we'll go to C. Suppose if I go to C, this C and then E is not matched. So we'll come back to again S, and then we'll take different route which is to SE. Now SE, SE. Now E and E is matched. So now this is matched and then this is matched. So now we need to match E. So we'll move this particular E to here. Now C and E is not matched. So we are going to get this false. So it is not possible from this particular cell. So we are going to return it as false from here. Now, as these two directions are not possible, we are going to try this particular direction as well. Now for this particular direction, we are going to have C, S and then E. Now E is also matched. After this, we are going to move to the next iteration, which is E. Again, E and E is matched. So all the characters which are present in the string is matched. So we are going to return false from here. Either we can return from here itself, or we can call to the next, and then word dots the index becomes word dot size. At that particular case, we can return true. So this one is going to return as true. Now this, and then from this we are going to return true, and then as we can find this particular word, we are going to return true from this particular cell, which will start from here. So these are the different operations which we can make, so that it will be so that the word can be found from the particular grid with different words. Suppose let us consider one more case where we need to use some other logic. Suppose let's say I have f and then c and then f. Suppose let's say I have the word f, c and then f. Now I need to find whether this particular string is present in this particular grid or not. So these are not matched, and then S is not matched, and then we'll go to F. After F is matched, we are going to go to C. Now the C is matched. Now there are four different routes where C can go to. Either it can go to this, or either it can go to this, or either it can go to this, or either it can go to this. Now we need to make sure that we will not visit the same character which is present. So suppose if I move to this particular character, again f is matched. Now we are going to return true from this particular case, and then it will go to this particular function, and then again this particular function is going to return true, and then this will assume as FCF is present. So that is not true. So that's why we are going to, whenever we are doing any operation, we are going to say that this particular character will be changed. Suppose let's say I am present here. Now after F is matched, I am going to change this particular character to some dot or any some other character other than the this particular character. Will not be using any character here. We are going to use some special symbol, so that we can say that whenever we come back to this particular cell, we can say that this particular cell is visited. So that's why we will not be using this particular cell, and then we are going to return it as false. So now this is done, and then we'll move to C. So C is matched, and then whenever it comes back to F again. Now this is no longer F. Now as this is no longer F, so we'll not be matching this dot with F, so we'll return it as false. Now again this is going to return it as false, and then at last we are going to return as false. So this is going to be our logic. Like, instead of using one more array or one more grid, we are going to use the same grid, so that we can use it back. Suppose let's say this return false, and then this is there is a dot operator. Now we need to replace it with whatever the word has right now. Why? Because it is already matched. So that's why we are going to use that. So let us go through the code. So we'll be using DFS traversal for this, and then we'll be marking each cell visited or not, based upon the word is traversed or not. Suppose let's say I have different cells which is present in the board. Now different cells will have different row and then different column. So we are picking a different row and then different column. For each particular cell, we'll start from this particular cell with the word, and then which will start from zeroth index of the word. Now we'll do the DFS traversal. This DFS traversal will return true if there is a word present which will start from this particular cell, and then if it returns true, then we have found this particular word from this particular cell which will start right now. and then we are going to return true. Suppose let's see the DFS traversal for this. So we are going to have four directions, which is up and then down and then right and then left. So that's why we are using a -1 0 and then 0 1 and then 1 0 and then 0 -1. So now we have board, and then we are going to have I and J, which will represent the row and then column of the board, and then we'll have the word, and then this will index will give the index of the word which we need right now. So suppose let's say the index equal to word dot size. That means all the characters which are present in this particular word has been matched. That's why we are going to return it as true. And then suppose let's say we have I and J, so those are out of bounds. That means it will be less than 0, or it will be greater than the number of rows or number of columns. That time we are going to return it as false. And then one more thing is, suppose let's say there is A present in the board cell, and then in the word index we have B. That means there is a mismatch between the characters, so we are going to return it as false. Now suppose let's say if this is not done, that means there is a match between the character which is present in board I and then J with word of index. So that's why whatever the word of index character is present, this will be present in the board as well. So that's why we are going to mark it as dot, so that whenever I visit back the this board ij, then I will have the dot operator instead of the same character. So it will not be match, this cell will not be used again in the same particular word. So that's why we are going to use it as dot. And then we are going to take four directions. Out of four directions, we are going to calculate by adding by adding the by adding it to the row and then by adding it to the column. So this will be our directions. And then we will match from the next index. Suppose we'll increase the index, and then we'll have this particular x and then y, and then we'll have the board. After this, suppose let's say there is a match, there is a DFS traversal, and then we got true. That means this word is found. So after finding, we need to make the board the same as before. That's why we are as we have set that board of ij equal to dot, we need to change the character which is present in this particular board back to original character, which is going to be word of index. Why? Because there is already a match. So if there is already a match, then this character will be same as this previously present character. So that's why we are going to mark it, and then we are going to return true. And then let's say suppose we did not find the word from these directions, and then we got false. That's why we are going to return false, and then we are going to mark the character which is present in the word index to board of ij, and then we are going to return it as false. Yeah, that's all for this video. Thanks for watching the video. And then if we come to the time and space complexity, we are taking the all the rows and then all the columns. Suppose if the rows are m and then columns are n, then it is going to be m into n. And then there is there is a length of the word length is k. Suppose if this particular word length is k, then what will be the different number of approaches we can have? Suppose let's say I have all the characters a, suppose let's say a, and then I have b. Now I have four possibilities for this particular character from the particular cell. Why? Because I can go to four directions, and then again I'm going to have again four possibilities, and then again I'm going to have four possibilities, and then again I'm going to have four possibilities, and then again I'm going to have four possibilities. So whenever I have size of size of k, then it is going to be m into n 4 to the power of k. So this will be the time complexity, and then space complexity is big of 1. Why? Because we are not using any extra space or anything. Yeah, that's all for this video. Thanks for watching the video.